So if you hadn't guessed, my talk today is about containers. This is something I've been hacking on for a while. But a little bit about me first. I'm a sysadmin for Anchor and a programmer on the side. I tend to do crazy things. I'm probably the only person I know of that's attempted to interface directly to the Linux kernel, directly with Python without any intermediate layers, which, funnily enough for containers, turned out to be a critical thing. Funny dog there. These are the people who were smart enough to ask me to do a talk, and I was stupid enough to say yes to. So if you need any managed hosting services, feel free to hit up our website. So a bit of background into how I got into containers. Back in 2010, I played around with OpenVZ, and I really didn't like the command line interface for it. I thought it was actually quite horrible, and I was quite vocal about that. We were evaluating it as one option for virtualization, rather than the Xen-based setup we currently had. So I went off, and when I had some time, wrote a proof of concept called isolation. It was a basic script that acted very much like chroot. And that worked amazingly well. Then I got a lot more time on my hands, and I had the second system problem where I wrote an implementation called Asylum that was a kitchen sink of pretty much everything. So it was containers and a library interface to all the security and low-level features of Linux. And that worked rather well, but it was rather clunky and wasn't actually that useful. But I did learn a lot about containers and a lot of the edge cases that would catch you out. The problem back in 2011 is that the containers implementation wasn't complete. And I'm not saying it's very complete at the moment, but there were things such as if you called shutdown in a guest container, it'd shut down the host, which might be a bug to some people, but I'm sure you can also turn it into a feature if you look at it hard enough. There's a number of features like that, NFS, which I'll mention later on, that do similar things. And if you think or look at it sideways, you can actually make it useful. So I'm currently working on some next generation code called Hammerhead, and that's basically a simplification of Asylum. And it acts more like a chroot. It's very simple. It tries and gets out of your way and leaves most of the setup details to you. This code is all available at the link down the bottom, dogger.io. And if you're familiar with Docker, you should be aware of who I'm making fun of. So what is this contained thing anyway? I've seen a couple of talks where people have said that containers should be renamed namespaces. But in my mind, containers are more than just namespaces. They're Linux namespaces. They're checkpoint and restore, so that you can do things like suspend and resume your container. But everything else is just standard Linux networking stuff. So if you know how to do networking under Linux, or resource management via CGroups, and know anything about the security mechanisms under Linux, that's pretty much everything else you need to know about containers. And so containers is all of this. Namespaces are just a small part of containers. I won't actually talk about checkpoint and restore. It's a great project, and it's not just containers specific. If you need to checkpoint your app, it's good for that as well. If you want to find out more about it, look up CRIU online. There's a lot of good videos, and I believe there's some talks at last year's LCA on it. So let's talk about namespaces first. Containers aren't a new thing. There's been similar implementations in other operating systems, and several previous attempts in Linux. So as you can see here, there's chroot, which I actually consider a form of container. I'm sure everyone's played with that at some point, probably if you're installing or building Debian images. There's also FreeBSD jails and Solaris zones. Funnily enough, I didn't find a lot of information about them online, but apparently a lot of people are using them. The last three are all Linux specific, so if you've ever played around with the budget web host, you might have heard of OpenVZ and played around with it, and then tried and loaded a module and been unable to do that, especially if you're doing VPN work. There was Linux vServer, which is not as popular, but a couple of other hosts online have been using it for the past 3 years. User mode Linux is an interesting one. It's an architecture that you can compile your kernel under that runs, so that allows the kernel to run as a process under Linux. If you're debugging device drivers, this can be quite handy. But as we'll see here, we've actually what we've come up, or what the kernel guys have come up with, is a much nicer implementation than what you can do with UML. So namespaces. Probably the most succinct definition of a namespace I could come up with was it presents a subset of host resources to a set of processes. If you're familiar with chroot, this should sound very, very familiar. It presents a limited view of the file system to the process you call, or passing as a command line argument and all its children. The interesting thing about namespaces is that they're highly granular. If you had a look at the FreeBSD or anything on that list apart from the chroot, they were very much all or nothing approaches. I'll go into the actual individual subsystems in a moment with the namespaces, but the items here are normally about emulating an entire system, whereas namespaces allow you to just pick and choose the features you want. You can pick and choose any features you want. They're not tightly coupled together. In practice, only a few are actually useful. And some combinations, if you don't use some combinations, they're actually security holes. They map fairly well to logically distinct subsystems in the Linux kernel. So if you've ever done a kernel compile and looked at all the subsystems there, you should be able to see what the namespace maps to. The important thing to remember is not everything is namespace aware. The big one in regards to this is NFS, as I mentioned earlier. If you have a guest with a VPN to an NFS server somewhere on the internet, and you call mount in that guest to mount the NFS server, it'll actually use the host's networking rather than the guest's networking as you would expect. And as I said, if you look at anything the right way, you can turn it into a feature. So if you want to present you want to allow a guest to have secure NFS mounts that they don't know about, you could actually use it in that regard, in that way, where the host knows where the NFS mounts are, but the guest doesn't. But the guest can still mount those. But as I said, that's looking at it a very, very slanted way. And this, not everything is namespace aware can catch you out. There we go. So what namespaces are all available? Well, as I talked about earlier, I actually consider chroot to be one of the earliest namespaces. The mount namespace is actually interesting because it's been around for a while as part of the clone syscall. If you've ever poked around in the etc security folder on most distributions, you might have seen references to polyinstantiation, which allows a user when they log in to have their own isolated temp directory. And this is actually done via the mount namespace. So what happens is they log in and unshare the mount namespace. And then they remount the temp directory. So only that user can see the temp directory, and you can't have you can't have files accessible between different users in the temp folder. The UTS and host or /host name is pretty simple. It allows each container to have its own different host name. I tend to find I enable this by default in all my containers, even if it's just for identification purposes. IPC is about locks and shared memory and semaphores. I don't actually deal with that very much. I don't actually find it that useful unless you're emulating entire systems. But just be aware it is one of the namespaces. Oops. The next three, networking, PID, and UID, are probably the most interesting and the most useful. The networking namespace allows you to fork or give a container its own view of the networking stack. So a set of processes can have their own network interfaces, their own routing table, and their own firewall. And this actually allows you to do some interesting things. Most of my work and day-to-day uses with containers is via the network namespace, where I use it for emulating networks. So you can easily spin up a network of 20 or 30 machines quite simply, but share the same root file system. So you don't need to have multiple container images. You can just launch processes in their own network namespace, wire them up together, and then start testing your networking stuff. And the IP route 2 command has native support for networking namespace. So if you want to have a quick go with that at all at any point, you can just type sbin IP netns. The other two namespaces, PID and the UID, are very useful if you're trying to emulate full systems. The PID namespace allows you to hide processes from a container. So a parent container can see all the processes, PIDs of the children, but the child container can't see the process IDs of the parent. So this allows you to effectively isolate what a container can see. So containers can't see other containers. If you're in a shared hosting environment, this might actually be quite beneficial. UID mapping is interesting. This allows you to give root that's actually not root to a process. Behind the scenes, it does one-to-one mapping of UIDs outside the container to UIDs inside the container. So you can map UID 0 inside the container or root to UID 1000 outside of the container. And this basically means you can hand out root to people and they can't do any damage to the system. Well, that's not necessarily true, and I'll get into that further, but effectively you can hand out root to users, which is, if you're testing programs that need to run as root, it can be very useful to just launch them in a UID namespace. I will point out that most of these namespaces are available in modern distro kernels, with the exception of UID. The UID namespace has had some security issues in the past, and for the moment it's staying disabled. I also believe that the ability to hand out root to arbitrary processes is a bit freaky, and it does mean you have to think about security slightly differently and how to secure systems that have the UID namespace available. So if you want the UID namespace, you will actually have to compile a custom kernel. And that's not a loadable module. You have to do a complete recompile for that. Okay, so what do these look like? The namespaces can either form a hierarchy or be completely isolated from each other. When it's a hierarchy, processes in the parent namespace can actually see all the resources of the child namespace. This becomes really, really important when you're managing things, managing processes such as with the PID namespace. It means you don't actually have to jump into the namespace itself to manage the processes in that namespace. You can just be in the parent, look at the CPU usage and just kill that process, which is really, really quite nice. In the isolated case, there's nothing shared between the namespaces at all. So there's no visibility from the parent into the child. So what does this look like? Well, as you can see here, A in this case would be the host, C would be a container, and D would be a container inside a container. And if you hadn't have guessed from my talk about talk title of Linception, you can actually run containers to arbitrary depths. So containers inside containers inside containers. And this actually turns out to be quite useful. It allows you to do some very, very interesting things rather than just doing the full system emulation. Okay, so back to the visibility thing. In this hierarchy, A can see all the processes of C, B, D, and D. However, E can't see any of the processes in C, B, A, or even D. So everything, you can see downwards, but you can't see back up or to the side. If you prefer buckets, then this is the way to look at it. A can see into the bucket, the C bucket, the F bucket, and the G bucket, and C into the F and the G, but G can't see B or even A and has no knowledge that it even exists. This is what the completely isolated case looks like. There's nothing shared between them. They're completely empty snapshots that you can do whatever you feel like with, and there's no interaction between them at all. The one thing I've noticed when dealing with containers is people tend to use them for isolating just a single application or for emulating an entire operating system. From my research over the past couple of years, this appears to be the wrong approach. We've already got something that's really, really good at managing single processes, and it's called the Linux kernel. I don't know why you'd want to reinvent that and replace PIDs with host names. There is a bit of a gap here, as you'll see. The container is great, but it's not great all the way up to a full OS. In fact, I'm thinking of calling it a system or something, but this gap between the capabilities of containers and operating systems seems to be occupied by OS management tools. So if you want to be doing things like LVM or RAID, I actually recommend doing that outside of the container and considering that part of the management tools for maintaining the operating system. And I think this is important. I really want people to start exploring this container space rather than just the OS or the process. So getting the management tools outside of the containers themselves and moving them upstream and having them managed higher up the chain. From my experiments and playing with it, this seems to work quite nicely and also reduces the file system image sizes. So if you're pushing bits over the network to jump around, this speeds up your boot times, which are already relatively fast with containers. And I might point out, you might not necessarily want to be running an int, as int is an init system is halfway between the system and the OS management tool. So it's really on the border here. There we go. So it really sits there. And haven't quite decided on what side of the line that fits. I think it's probably application specific. So how do you implement containers? As I said, I've written 3 implementations of containers now, and every time I go off and do this, I end up using the same starting the same 6 syscalls. 3 of them are used for actually starting up the container themselves, and the other 3 are mainly to work around bugs that I found, well, not bugs, but unexpected behavior in glibc, and for securing the box, and also just general setup. So I'll start with the items in red there, which actually are for implementing the containers themselves. So clone is relatively simple. It's actually used to implement fork under glibc. You pass in flags, you get a new namespace. Any other processes you launch after that point are not in the namespace, they're in the same namespace. They're in the parent namespace. glibc actually gets in your way quite a bit. It forces you to specify a base address for the stack, whereas sysclone, which is what clone calls, allows you to just pass in 0 and get copy on write semantics, which is a basic fork. When you're in Python, you don't necessarily know where the stack, where the base of your stack is, and you don't want to be filling with that at all. So my solution for this was just to bypass glibc and call sysclone directly. And that fixed a lot of my issues, but that in itself had some minor issues, which I'll get into later. Unshare is slightly different, whereas clone will fork a process and put the new process in the new namespace. Unshare specifies what happens to all future forked processes. So it'll create a namespace, and then every process you fork from that point on will be in that namespace. If you're going to use clone or unshare, I recommend only choosing one and not the other. Only choosing one and not trying to choose both, because they will interfere with each other. If you call clone and then you call unshare, your processes will actually be in 2 separate namespaces. If you want to jump into an existing namespace, you have to use a different command, which is on the next slide, and has a similar interface to unshare. So I'd actually recommend using the unshare syscall because it allows you to reuse code with the setns on the next page. So this fork model is actually nice. I mean, if you've ever done anything with forking and writing daemons, you know about how to track processes and wait for processes to exit. Because a container is just a forked process, you can call wait PID on it and wait for it to exit and get its exit code. And because there's nothing new to learn apart from how to fork off a separate child process. As I said earlier, I recommend using clone rather than unshare. It's easier to spawn multiple separate processes in the same namespace. You can't do that with clone. As I said, every time you call clone, you get a new namespace. What I've found is I tend to launch the init into the namespace and then freeze it before it actually starts. And then run a whole lot of programs to set up the container. And unshare is a bit easier to do that with. If you want to keep a bind-bound namespace alive after the process has exited, so say you set up the network exactly how you want, and then you want to go away for 3 days, but you want to kill off the shell that's in there for RAM, if you really need 2 megabytes. Then you can bind mount the namespace file descriptors, which I'll get into once again later, to a directory, which keeps a reference to the namespace open and it prevents it from being cleaned up. The setns, this is a command to jump back into an existing namespace. So if you've bind mounted it, you can use this command to jump back into that namespace. As I said, like unshare, all the once you call setns, all the child processes end up in that namespace from that point on. And hence why I recommend using the unshare, because in practice I found that there's a lot of code sharing between jumping back into an existing container and creating a new container when I used unshare. So you basically give it a file descriptor and the namespaces you're interested to, and call it, and then that's all you have to do. The namespaces themselves, or the references to the namespaces, live in proc self ns. If you've got a machine in front of you, if you ls that directory, you'll probably find there is a ns folder. And those are the files you can bind mount to other locations. So the file descriptors you pass in don't necessarily have to be from proc self ns. They can be the location you've bind mounted it to. I actually recommend using this, or considering this as an alternative to SSHing into boxes. Basically because of what is said there, why do containers need to run SSH anyway? Why can't you just SSH into the host and then have your shell set to automatically jump into the container? It'll save you a bit of memory, and if you got 500 customers on the one box, there's a gig of RAM, if it's 2 megabytes for an SSH process. So one of the things I've been trying to, one of the motivations for doing my talk is to get people thinking about containers and how to do things slightly differently. Not necessarily throw the baby out with the bathwater, but just to start thinking about, containers allow us to do some interesting things, so can we use that to do things slightly differently in a slightly better way? And I think putting the SSH outside the container is one. If you want custom options for an SSH, there's nothing preventing you from running SSH in the container. It's just, initially I just give them direct access outside of the container. Okay, so set hostname. I actually realized that during my setup work for the container, initially I was just calling bin hostname, but due to my security model, I was actually disabling the ability to make the set hostname syscall for the container. Yeah, from in the namespace, but I still had to set it, and I realized that for that small phase, I actually have to have privileged access. I actually tend to do more than one thing at a time. So I was doing networking and other things like that. So it wasn't just privileged access to set the host name, it was privileged access to stuff around with the host system. So the solution I found is just call set host name directly. Don't call out to user binaries, you can't trust them. It means you do have to implement a bit of functionality, but set hostname was a single syscall. It was fairly trivial. And I didn't actually find there was much beyond that I had to implement myself. Get PID was another interesting one. I tore my hair out for a long time about this, but glibc caches the output of get PID. So you call it the first time, and it'll put it aside so that when you call it, it never has to call out to the kernel. I was having a big issue where I was printing the PIDs for comparison and to confirm that I'd actually gone into a namespace. And I wasn't seeing the results I was expecting. I was seeing the host's PID, I was seeing the parent's PID printed twice. And I realized it wasn't just because I was calling clone directly, but it was also because I was calling sysclone directly. So my solution was to directly to expose the get PID syscall and just call that directly rather than using glibc's version. I don't know if other people have that issue, but that is just something to be aware of if you're going to go off and implement containers. Yeah, so my solution was once again to bypass glibc. Now I don't know if that's actually a good idea, as was indicated by the dog earlier. If anyone's got good solutions for these, please come and bug me about it, because I'd love to know. PR control. I find that not enough people know about this feature of the Linux kernel. It allows you to turn on and off a whole lot of interesting things. And there are security features in there that when you're implementing containers, you might actually want to use. Seccomp v2 is one of them, which I'll go into later. I recommend hitting up the man page, but also realize that the man page is out of date, and probably poking around in Google is a lot better. In fact, I found the biggest issue I had with containers is that a lot of this is undocumented. A lot of my efforts into containers was collating the information, putting it all in the one place, just for reference material. And I'm trying to make that available and start documenting things and improving man pages, just so that other people can go off and implement containers easily and not have to spend 4 times the amount of work or 4 times the amount of programming time to just find the information needed to do the programming. So namespaces actually bring some interesting files or add some interesting files and do interesting things to the files in proc. You might have seen references to proc selfnet in the proc folder and wondered why it seemed to be a duplicate of the data in procnet. Procnet, this one, I forgot my mouse. This one here holds all the network statistics and connections. So if you've ever done a netstat, it's got similar output in there. It's great if you need to script something and netstat doesn't give it too easily. This is actually containers aware. So if you're outside the container and you need to see all the connections inside the container and you don't want to jump into the container for whatever reason, you might not trust the netstat binary, you can just look at proc and then the PID and then net, and you'll see the connections only inside the container, even though you're outside the container. Same for mounts. If you want a list of what's mounted inside a namespace, just find the PID of a process in that namespace, go to proc PID mounts, and just cat that. I mentioned the NS, that's actually a directory with file descriptors in there. What's in there is what you pass to the setns. So you open a file in there, that'll give you a file descriptor, you pass that to the setns command, and you get a namespace magically. The UID and the GID maps are used for the UID namespaces. It's actually a simple format. It allows you to map regions of processes, UIDs or GIDs, inside the container to UIDs or GIDs outside the container. It's a fairly simple format. You've got the start of the UIDs inside the container, start of the UIDs outside of the container, and the amount of UIDs to map. Just be aware that you can only have a maximum of 5 lines or maps in there at a time. And I've got a feeling that's not going to be enough. I've hit that. I've gotten very, very close to that limit very, very quickly just in testing trivial examples. And I'm thinking 10 is probably a better number. But I still need a bit more experimentation in that area. If you're doing, well, as I said, namespaces just uses standard Linux networking. And there's been some interesting stuff added to the kernel that's directly relevant to the namespaces. I tend to find that these are the two things, Mac VLAN not so much, but vEthernet and bridges. vEthernet is basically a virtual Ethernet pipe. So packets go in one end and they come out the other end. The nice thing is that you can put one end in one container and one end in another container, and suddenly those two can talk to each other. So yeah, useful for joining together. You can even put one end in a bridge. And if you do that, it starts to look like standard libvirt networking or the Docker networking model. Most people tend to go for the bridge with the virtual Ethernet, but there's actually there's some other networking paradigms that are also interesting if you're willing to play around with it. Mac VLAN is basically is just almost direct access to the real Ethernet device. It just uses a different MAC address. I'm not going to say much about that. If you need that, you'll know about it. It's very, very application specific. I haven't actually found much use for it in real life. This is an interesting one, and I'm probably not going to get a lot of time to get through all of it. But there is no one security subsystem in Linux that does everything you want. I found you do have to mix and match a bit, and there is a bit of overlap between them. I've had to think very, very long and hard about the security of containers and how to implement them in a nice fashion that can't be exploited. And it is possible. You just have to be aware that you can't just use one Linux security feature and get everything. There are also, once again, some interesting opportunities. If you start doing things differently and you move the OS management tools outside of the container, you have less security issues to worry about, because a lot of the things you're going to restrict are management syscalls, for example, and access to management features, which would allow you to get outside of the container. So these are the basic subsystems you need to know if you're going to start implementing security on containers. I'll just run through these quickly because I'm about out of time. The CGroups, normally used for resource accounting and limiting, and just for tracking PIDs. It does have a nice basic security like CGroup called device CGroups, which allow you to restrict read, write, and execute permissions to devices on a per PID, on a per CGroup basis. It's not the best. I know a lot of people online hate it, but I really, really like the API and it works quite well for that. Capabilities. As I said, if you move the OS management tools outside of the container itself, you can actually drop a lot of capabilities, and that massively reduces your attack surface. As there are a couple that are useful inside the container. As you can see here, there's a capsys boot, which is the one that allows you to reboot the system. So if you remember earlier, I said if you executed a shutdown command inside a container, it would shut down the host. If you're running a kernel greater than 3.9, you actually do want to grant this to a container because it allows them to exit gracefully. Capsys root is another one that you probably do want to provide, because I'm sure there's a lot of programs out there that are using the root for security and don't expect that command to fail when they're running as root. Seccomp v2 is probably the most interesting thing I've seen so far in relation to containers. It allows you to not only restrict specific syscalls, but also filter on the arguments to those syscalls. So this allows you to do things like disable most of the I/O controls, but not all of them. So it can still allow TTY management, but not allow raw access to low-level details of the hardware and use that to compromise the system. In practice, you probably want to use a whitelist. If you run a series of processes through systrace, you can probably get a fairly good idea of what you do and don't need to enable. But you definitely you're going to want to have a look at this at some time, because this seems to be the best, or one of the most flexible ways to secure containers. I also recommend looking at SELINUX. When I actually started looking at the documentation, I actually found it fairly simple, which contradicts a lot of the stuff I actually read on the internet. The one thing that's probably the most useful in terms of containers is multi-category security. And I'm just going to skip through this. Actually I don't have that slide anymore. But basically you tag every single container with its own category, and by default categories can't access the resources of another category. So if resources or files from one container leak into another container, they won't be able to be read or written. So it's cheap security. I found it was 5 lines to implement and gave me massive security, or much better security guarantees. If you're going to work on config file formats, for containers, I found it tended to break down into 3 groups. So you've got stuff that concerns the container, stuff that concerns the file system, and stuff that concerns the networking. So I'd recommend breaking your config files down into 3 sections. And containers just contains the UTS, UID, PID, IPC, but it might also contain what you set the maximum memory to in the C group, the host name, and other things like that. So there are some things I would like in Linux. The top one, I don't actually know if it's a good idea. I can emulate it at the moment by forking, setting myself a sig stop, and then when I get a sig continue, executing the process I want. But this seems like a much nicer solution. Funnily enough, it was the glibc guys that recommended this be taken out because no one was using it. I don't know whether or not it's a good idea to add it, but if anyone's got any comments on that, I'd like to know. And if anyone knows of a really good way to get the PIDs of the children of a process, please contact me, because it's probably not the most safe way of doing it, but there are times where it is actually handy. At the moment, I'm building the entire tree from the parent PID and then reversing it to get all the children, which means I have to hit every single PID, which is slow, and there's lots of race conditions there, which took me forever to fix up. So if you want more information, I'm trying to document everything related to containers at dogger.io. I've also got some networking information on pocketnix.org. So if you're interested in the network namespace, I'd recommend going there. LWN is probably one of the best resources for this. Containers mailing list. There's man pages published on there, but that were never actually put into the kernel man pages repository. So, and they're quite informative. If you've got any questions, either talk to me at lunch or email me. Thanks for that. Move on to questions, I suppose.
We've got several minutes for questions, so Jay, if you just repeat the questions when they're asked to you.
Yep, no problems. Yep.
I'd like to talk more offline later, but the main question I've got is, what problems did you find with, I noticed you mentioned LXC on the website. Why did you go and design your own wrapper around the kernel stuff rather than use LXC?
When I originally started playing with this, the only option was LXC. So this was back in 2010, and new things have come along. But the one thing I discovered is this is actually really, really simple. It's just forking, and you're in a new namespace.
So it's overkill, you think? LXC's overkill?
I wouldn't say it's overkill. But once again, LXC assumes the server model where you're trying to emulate an entire server. And everyone's going all or nothing. And I think there's some good middle ground to be researched, to look at. So, yeah. Yep.
What's your opinion of Docker?
My opinion of Docker, I believe it is a glorified script, shell script or Go script around wget and LXC and doesn't deserve the praise it's getting. LXC definitely deserves a lot of praise. So does systemd nspawn, which I actually used for, as reference for a lot of my stuff. But Docker, I don't think actually brings enough to the table for me to be interested. And once again, it does the app isolation, which is great for if you're a platform as a service. But once again, I think there's more interesting paradigms out there that we should be looking into. Any other questions? Yep.
Dude, demo ever
Yes, I should give a demo, shouldn't I? I should actually prove that this stuff works. So, as I said, I've been working on a program called Hammerhead. There we go. It's literally all Python, as we can see here. So, what I do here is I set the host name to this is a test. As I said, this is where that hostname thing comes in handy because you don't want to be doing rm-rf / outside of a container. I haven't made that mistake yet, but hostname helps prevent you from doing that. The PMIN is just PID, mount, IPC, and network namespaces. So after we've done this, we should only see the processes inside the container and no networking interfaces. And I actually emulate a Chroot model. So what you see here is a path to a Debian SID installation, Wheezy installation, sorry, that I just use for testing. So what I'll do, okay, so I've got lots of, PS2 is probably better. I've got a lot of processes here. Now I should point out that at the moment I'm running it as root. If I did use user namespaces, I don't actually need to run as root. That's one of the nice things about user namespaces, but everything's a bit in flux, so I don't really want to get into more about user namespaces at this point in time, because things could change massively. And I'll point out that this is a custom compiled kernel with all the namespaces available, but this should work on any standard distro kernel. Okay, so we're now in a container. PSUAX. It's a very, very minimal container, as you can see. In fact, there won't even be PS trees, I know. Let's go into the proc folder. So you can see there's PID1 and PID4. I've hard-coded the terminal there for various reasons, but let's try xterm. And we'll go back to that, and you can see there's two processes there. And we can kill ourselves for fun. And networking. There's only a single loopback device that's actually in the down state. Whereas if we go up, you can see I've got a crazy amount of network interfaces here. So we'll clear this for the moment. And we'll see the host name is no Dachi. And in the container, host name is this as a test, which is what is specified in the command line. And we can change that in the container. And we'll see that the host name in the the parent hasn't changed whatsoever, which is handy. I might just quickly also show 360 sleep. Okay, 583. And if we catnet and we want to look at the TCP connections, there are currently no TCP connections in that container. However, if we do cat proc self net TCP, I currently have TCP connections open. So the top window is actually outside the container, but I can peer into the state of the network from outside the container, just using that proc self net directory. Yep. Anyone have any questions? Any more? Yep.
You mentioned systemd nspawn.
Yep.
Could your work eventually feed into that, or make a different? Like, where's the bridge between you and systemd? What would keep you separate?
Mainly that I'm written in Python. Oh, yeah, sorry. What's the difference between my program and systemd nspawn? And could my work be integrated? Probably not. As I said, my work's in Python, and it's mainly to allow me to test and play around with this sort of stuff. Systemd nspawn, if I remember correctly, is about running binaries on your system in a secure manner, where I'm actually looking to jump into chroot machine images. So that's probably the biggest difference. I'm trying to make a better chroot at the moment, whereas systemd nspawn is just trying to secure a single process on a machine. But as I said, it makes a great reference implementation, and the code's relatively easy to read. So, any other questions?
Last one.
Excellent. Well, thanks for having me.